Is your mic low or is my speaker low?
Is my mic bad?
Like
Is that
low,
better? Is this better?
maybe. I don't know if it's. I think it's me because usually it lets me. It lets me put on like speaker or something. I don't know.
Oh, I'm not sure.
I don't know what it is.
Okay. Oh, hi, Ben.
Can Ben be the new teacher?
He can do whatever he wants. Okay, wait. I'm gonna load up the screen share, the live stream. I
You're
think
getting fired, bro.
I'm getting fired. Oh no. Okay. I think. Okay, I think there's a live stream link. I gotta get it real quick. So you wanted to do. What is this question? How much work does gravity do on the body as it executes the motion?
Yeah,
So,
we can't see your
oh
thing
yeah,
though.
you can't see it. You're right. You're right. Hi, Caitlin.
No,
So
gotcha.
it's for this question, work is f. It's the integral of f dot dr. It's just force times distance, right? Distance. The distance is so it moves from y1 to y2. Okay, so the distance is going to be y2 minus y1, right? That's a negative value, which is correct because it's going, well, actually, no, it's going, gravity's negative, but also the displacement's negative. So that means that you're going to have a positive value. So you could do like mg y2 minus y1 is the answer, but g's got to be like negative 9.8. You got to clarify that it's not positive 9.8 because otherwise you could be wrong. It depends on the signage. So that's the answer for that question.
Wait, you don't need to use the integral there though. You're
No,
just
you don't
doing
have
it
to use an integral for this. This is
because
a
the
physics.
force will always be mg.
Yeah, this is physics 1 and 2 as well. It's the same thing. Yeah. Does anyone have like a specific question? Like if you want, you can even like click the raise hand button to speak. Oh, yeah, one sec. Okay, I'm gonna move you down a sec. Alright, Caitlin, you gotta click accept.
Hi, JT.
Hi,
JT.
Oh my god, how many people?
Okay, wait. We have a question.
Yeah.
You want to read that? Wait, what is that? I will screen share. This is Unit 3 progress check MCQ. Okay, wait, JT, let me screen share it too.
I don't know that you can screen share, but if you send a screenshot in like the general channel, I can load it.
Wait, Unit 3 progress check FRQ1. MCQ. MCQ? Oh my god, why haven't you done this one? Yes. I just done a new.
I don't even know who I'm hearing, I'm not gonna lie.
Oh, Kaylin. Take a guess. Take a guess.
Take a guess? That's risky. I feel like that's a bad idea. I mean, I'm gonna assume Emma's there because I don't know.
Who else?
Who else?
There's 3 people.
There's 3 people. Wait,
You got Emma. You got Kaylin. I played Roblox with you.
that I played Roblox with a million people. That tells me nothing.
In Mr. Cadmus's class.
Oh, Emily. Hi, Emily.
Okay, I sent it.
Okay.
Send the answer. Oh, or actually, don't send the answer.
Why send the answer? That makes it less fun, right?
No, I mean like, okay, sure.
We don't have faith in me. In figure 1, a person uses a pulley. The pulley's pulled down at a constant speed, power P1, and the bell moves upward at a constant speed. In figure 2, they use a double pulley. Okay, the person pulls down the rope at the same constant speed. Okay, but the speed of the bell is half the speed in bell in figure 1. Okay. Sure. Okay. So which correctly compares and provides I assuming that like okay, so the pulley's doing I see. So is the pulley being pulled upwards? Is that what it's saying?
I guess. Wait, let me read it again. Yeah, uses a pulley to lift a bell.
Okay.
So it's getting pulled downwards. You're pulling the rope downwards, but the bell's going upwards. It moves upward at a constant speed.
Okay, sure. So setup 1, figure 1.
Sorry. He does that.
So you just have some constant force.
I'm scared just gonna bite my face. I don't want to
F times the constant velocity. Is equal to P1. Figure 2. if we do like the setup for this,
That's not
like the free body diagram, you have mg downwards, and you have f upwards. I don't know what you would call, like, is it saying that the pulley is physically moving upwards, I guess?
I have no clue.
Yeah, the bell again moves at a constant speed, but the speed, okay. Is it like as straightforward to say that like the speed is half, so it's like f times v over 2 equals p2? Is it like that straightforward? What happened?
Why would it be f times v over 2?
Well, it says it's moving at half the speed.
Okay.
Powers. Do you have the answer key on you?
Yeah, they're long answers. So do you want?
Oh, it's a long answer, so there is more to the problem.
No, not long answer. It's like the what's
What,
called
what
it.
did what did it say
answers
was the
are, like-
ratio?
What do you mean?
What did it say was the answer?
Screenshot.
Yeah, you can send that. So if assuming this is the correct way to do it, if you factor this out, you get f times v equals p2, and f times v is p1, so 1/2 p1 equals p2. I don't think that's the entire question.
If
It
we
was-
sent the answer key,
Not answer.
not answer key, the responses. Yeah.
Okay, sure. So they're both have to have enough force to lift the bell up, which has the same mass. So the forces exerted are going to be they're going to be the same, I guess, since it's moving at since it's moving at a constant speed. That's important information. That means that F net is 0, right? Because otherwise there would be acceleration. F net is 0. So that means the force of gravity of the bell has to be equal to the force pulling upwards, right? So that means they have to have the same force because the bell is the same force of gravity, and in both situations they're moving at a constant speed. So that means they do have the same force, all right? And since power is just force times velocity, one of them has half the velocity of the other but the same force. So P2 is 1/2 of P1. So that tells you that P2 is less than P1. Let's see what. Okay, the force. So it would be option A.
Option A.
Does that make sense?
Oh, and that's correct.
Yeah.
JT got it right.
You are a genius.
You
I
are
mean-
smarter than Michael Jennings.
Then who?
The physics tutor got it wrong, apparently.
You have a physics tutor?
Yes, I do, because I suck at this.
Oh, okay. Well, I mean, it's hard. I would say everyone sucks at it to some extent. You think Mr. Wong doesn't get questions wrong?
Yeah, but that's C. I'm in 1.
Right now, our curriculum's not drastically different. There's like some calculus. I don't know. Usually people join, but they don't like because I'm doing it so early that less people tend. It's usually I do it night before kind of thing, like at 9 p.m.
That's crazy.
Like if you guys have more questions or just want to go over concepts, I don't mind.
You want to do springs?
You want to
Oh,
do
yes.
springs?
Springs. I want to do springs.
What about springs?
We get to do
Oh my gosh, next.
Remember
Yeah,
what we
yeah,
had in the last like quiz test thing where it was like that the spring with conservation of energy?
You
First
have a
question.
setup for that?
No,
First
you just add the spring and concept.
But one
Yeah.
important thing to
Yeah.
note, like if you have let's say you have a spring, right? Like an object that's hanging down from a spring, and let's say
Mhm.
this is equilibrium, right? X equilibrium, and it's displaced some distance. Let's say we can call it like XR. If you want to actually do if you want to find let's say it's pulled down that distance, and we're given that the spring constant is K, right? If you want to find what speed it's passing through at the equilibrium point at, you're actually not using, you're not actually gonna have an MGH term. It's just the nature of you kind of have to understand this. With a vertical spring, if it's attached to the object, you don't need an MGH term for the displacement, because this term automatically handles the displacement, the vertical displacement. Like normally you would have, if you drop an object onto a spring, you would have something like MGH is equal to 1/2 kx squared. Like if a block was being dropped onto a spring of some sort, you would have something like that for your conservation. But because this is a vertical spring moving and it's attached, it's just the nature of it. You kind of have to know that. I think Miss Donahue had a practice. You guys have Miss Donahue or no? You have Marvin.
We have Marvin.
So I think there was like a practice question where basically, how do I explain it? So basically there is no MGH term Because springs can automatically account for the potential energy of gravity if they're vertical.
These are associations. Yeah, he just feels fun.
Yeah, I've heard interesting things about him. So
Oh yeah. Oh, like
do you guys know what a parent weight is?
No.
Oh wait, also I saw a question and it asked me for something something equilibrium. What is that?
Translational equilibrium.
Yes, he never mentioned that before.
I'm assuming that's just when it's. Oh man, I keep closing that. Sorry. I'm assuming that translational equilibrium is when there's no, I think, no forces acting on it, right? I think it's just no forces acting on when F net is 0. Yeah, the net force is 0. So like it could have a constant velocity, but what matters is that the F net is 0. That's all it is. There's no acceleration.
Okay.
Likewise, rotational equilibrium. Have you guys done rotation yet? I'm assuming not.
No.
Okay. Well, stable equilibrium for rotation is just when there's no torque, which you'll get to. So yeah, that's what translational is.
JT, we don't really care about torque yet.
Yeah. I know. But there's like I think someone's watching the view, whatever the YouTube.
Oh, okay.
This on YouTube?
YouTube?
Yeah, I do
What's that?
YouTube. I did YouTube because a lot of people were complaining that they don't have Discord. So
Oh, oh wait, oh that's so cute. We're on YouTube right now, guys. Are we famous?
for all 0 or 1 people,
Who's the one person?
I don't
It's
know.
YouTube.
It doesn't let me see it.
I'm gonna see for Discord, right?
Yeah, people can see on Discord. No, we're not very busy today.
Wait, can you go over like centripetal
Centripetal
force and like
force.
universal gravitation?
What? I printed out this. It's so pretty. If
Have
anyone
you
wants.
have you
It's
guys
correct.
done like FG equals like negative G M1 M2 over R yet?
Yeah.
Yeah. You mean negative G?
Oh well, it can be
I
negative.
thought
It
it was-
depends. It doesn't matter.
It's
Absolute
negative.
value. Okay. So
Wait, boy.
Wait, it's negative G?
it can be negative. It depends on the context.
Because no, I haven't used negative this whole time.
Because it's just absolute value. Because it's
Yeah, there's an
Okay.
absolute value, so it doesn't matter.
Okay, good.
So if we're looking for something specific, have you then find the period of rotation of orbit?
Yeah.
So I'll make this mass of planet and mass of satellite. So MP for the mass of the planet, mass of the satellite. So let's say we want to find the period of an orbit. We have our centripetal force is going to be gravity because around an orbit, gravity is always pointing inwards no matter where you are. So that's the centripetal. So we're going to set gravity equal Fg is the net force, which is equal to centripetal force. Centripetal force is a net force. So like when you draw a free body diagram, you would never label Fc, force of centripetal, you would label like force of gravity or whatever. That would lose you points. So gravity is the centripetal force, and we have a formula for centripetal force. In this case, it's going to be mass of the satellite times v squared over r. And we're gonna that's Fc, and it's gonna be equal to G MP M satellite over R squared. So what we can do is we
Wait,
can
why
cancel
are FG and FC equal?
because the only force. So we're looking at, let's say this is like a planet, like or the sun, right? And we're looking at the orbit of the Earth. The Earth is here, right? The only
Yeah.
force acting on the Earth is gravity, the gravity of the sun, right? And so that
okay.
means the net force is equal to gravity. Gravity is the only force. So it's the net force. And centripetal force is a rotational net force. It means the net force is rotational. So our centripetal force is equal to our net force here. And gravity is equal to our net force. So, like,
Does
does that make sense?
Yeah.
They're both.
Yeah, that's good.
No,
Yeah.
not MV squared over R, isn't it?
MB squared over R is another. Okay.
No.
So this is
Wait, so
centripetal
we just have
force.
to memorize. We just have
Well,
to
these are
memorize
in the
that MB
reference
squared is
table. But you should understand
squared over R.
conceptually the only force acting on the Earth is gravity, and it's centripetal force here because it always points inwards.
Mm-hmm.
So we can set these. So we can set them equal and then we can do cancellation. Mass of the satellite cancels out. And that's a really important concept. That tells us that the velocity of an orbiting object isn't dependent on the mass of the object. It's only dependent on the mass it orbits around. So now we have gmp over r squared equals v squared over r. Alright, so it's not dependent on the mass of the satellite. So the Earth could be 10,000 grams, it could be 10 million tons, it doesn't matter. It doesn't affect the speed in which it orbits. We can also cancel out one of the r's. Alright, so what we get for velocity, velocity is gmp over r equals v squared. But there's also another formula for velocity from, I don't know if it's in the reference table, but you might have to memorize it. It's 2 pi r over t. This is for rotational velocity.
I don't
Yeah,
think
we
that's
did
that's
talk about
we talked
that.
about that. I don't think it's on the reference table.
Okay. So the reason this is because, like for a circle, circumference is 2 pi r, right? So if our planet has if something's orbiting at a radius of 1 meter, that means its orbit circumference would be 2 pi times 1 meters. So 2 pi meters. And it's saying and t is the period of revolution, meaning how many seconds does it take to do this revolution. So this is velocity because let's say the radius of the orbit is 1 meter. That means we're orbiting 2 pi meters in, let's say t is 1, so t in 1 second. So 2 pi meters per second. So that's our formula for rotational velocity. So we can actually plug that into here. So we're going to get g mp over r, and I'm going to go ahead and square it, is 4 pi squared r squared over t squared. That's the result of squaring it. Now, this square will cancel. Sorry.
Pi R2.
What's up?
That's an equation.
2 pi
That's
r
like
over
all
t.
It's not reference table.
Yeah, that's just something that you have to kind of know. Now, if we want to solve for the period of revolution, that's t is the period, we can put it over on this side. T squared equals 4 pi squared r cubed. That r goes over here, over gmp.
Wait, JT, why'd you square everything?
Yeah, sure.
It's
I
v
squared it
squared.
because we got v
Oh,
squared
oh,
from
oh,
mv
oh.
squared.
Yeah, okay.
So now we find that you kind of have, this is an important fact. You don't have to memorize it. I wouldn't say is 4 pi squared r cubed over gmp. So two really important things to know about this is that the period of revolution is not dependent on the mass of the satellite, only the mass of the planet. And you also want to know that the period of revolution is directly proportional to r to the 3/2. That's what that is, the square root of r cubed. So they're proportional. That's supposed to say proportional.
What? I'm confused.
Okay, so basically from this equation, this is a constant, this is a constant, this is a constant, this is a constant. So it's the square root of a bunch of constants times r cubed, right? That makes sense?
Oh, it's cute?
That's
Mhm.
cubed. Yeah, because we moved this r up to this side.
Oh, you
We cross
multiplied it,
multiplied.
okay.
Yeah. So it's r cubed. So that tells us if we ignore what these constants are, this just means proportional. That means the period of revolution is proportional to radius times radius to the 3/2. That's just because the square roots means to the 1/2 power, and that's 3. So t
So when I
is
say like double the period, it doubles the
so
square
like
root.
if you, well, let's say the period was let's say the period, I'm sorry, let's say the radius was 2 meters for some reason. That means the period would be what? Sorry, 4. Let's say the radius is 4 meters, right? That means the period is going to be 8. Well, 8 something. It's proportional to 8 meters. But in reality, we would have to plug the 4 into there. I'm not going to do that. But you just have to understand that this is the proportion that's true, and that the orbital period is independent of the mass of the satellite. There's no value for the mass of the satellite in this equation.
Hmm.
All right, and you can also just look at this formula here. This is also another important formula. V is proportional or equal to rad gmp over r. So that means that velocity is proportional or inversely proportional to the square root of r. Just like you don't have to memorize that, but generally speaking, you should understand it.
What does proportional like mean though?
Yeah,
So it's
sure.
not equal,
So
it's
let's say
just
like we say y is proportional to x, that means there's a linear relationship between them. So this is saying that like v has a linear relationship with rad 1 over r. So like if we graphed on the x-axis 1 over rad r, and then we graphed on the y-axis different v's, let's say it's like says someone measured some values and collected lab data. Since they're proportional, that means that it would be linear when we plotted it.
so like 2v is proportional. It would be like the same as
Proportion.
2 over r, 2 over rad r.
Yeah.
If you
Yeah.
double both them,
Yeah,
so
but
if you
that
double
would it would be like you could be asked the question like r is now 4 times as much. How will that affect v? So if we plug right
v is a quarter.
for r, that's gonna be like v over 2.
Oh wait, yeah, 'cause it's round.
Yeah, because
Yeah.
it's square root. So like it could ask you a question like that.
We've gotten this before.
Those are like the most important things with orbit. I'm trying to think of. I know Miss Donahue might have some better. Let me look at what I have. I don't think there's much to orbit. You'll be asked things like that. There's other centripetal stuff. It's not usually related to orbit.
Oh wait, can we do like like the tetherball questions?
I'm not sure.
Okay, never mind. I'll
Well-
try to find one.
Actually, Mr. Marvin copies Miss Donahue's notes. I might have.
Yeah, it's like the thing that's like a tetherball like slings around.
So it's like rotating, like a ball is rotating on the top of a stick or something by a string.
Yeah, and it's like what's the like something with the centripetal force and the tension in the string or something.
It says like how fast would you have to rotate it for it to snap? Something like that.
Yeah, I think that might be it. I remember it's like pretty hard though.
Sure. So let's say we have a question and there's some sort of pole, and this pole is attached to like a string, right? So some sort of pole, and the pole has a little rope that's attaching it, and attached to that rope is a ball, right? Let's say I don't think it. Okay, let's say the mass of the ball is it's a 1 kg tether ball for whatever reason. All right. And in this string, the maximum tension it can hold without snapping is 100 newtons, all right?
JT,
Yeah,
my grandma says you should be getting paid for this.
it's
And she
fine.
says you should go to MIT.
I should go to MIT. I didn't apply to MIT. All right, so let's say the maximum tension the string can hold is 100 newtons without breaking. So that's something we'd have to give you. You wouldn't know how much, right? So it says we have a 1 kg tether ball. It's being rotated around. So let's set up a free body diagram on the tether ball. Technically we have mg downwards, but that will kind of become negligible. We have force of tension inwards. So we're going to actually ignore mg because the force of tension will kind of cause the ball to stay upwards, so we're going to pretend it's not there. So for the ball, we just have force of tension. Accidentally moved that, sorry. Just force of tension. So like I said, centripetal force is an F net. It's a circular F net. So we only have one force in the centripetal direction, Fc, which is equal to Ft, alright? So we can set this equal to mv squared over r. And we're trying to find the maximum. Also, I'm going to give that the length of this rope is 2 meters. That's important. mv squared over r. So we have that this is going to be equal to Ft. That's equal to Ft now. And we were also told that the maximum Ft allowed without the string breaking is 100 newtons. So we gotta find when this is greater than or equal to 100 newtons. Alright? It's really, we're just finding when it's equal. That's the velocity that will be needed to snap the string. So given what we have, 100 newtons is equal to, we're given that it's 1 kg is the mass times velocity squared, and radius is 2 meters. Alright, so if we just solve for v, it's pretty straightforward. We're going to get 200 equals v squared. So the maximum velocity the string can endure is rad 200. meters per second. Does that make sense to everyone?
Yeah.
Okay. And the reason you kind of have to ignore gravity here is because, well, A, it's not in the centripetal direction, it's a centripetal question. But the tension of the string will actually keep the ball upwards so it doesn't fall downwards. So we kind of ignore the effects of gravity.
Okay. Okay, thanks.
Yeah. No problem.
How's your day going?
It's fine. I had 2 midterms today.
Two.
Who?
Oh, Spanish.
Yeah, Spanish and math. They were both not hard though. So
You get to hear my story about how I was driving to the math midterm, and I saw literally 5 people driving the opposite direction of school, like within 30 minutes of the math midterm starting. So I seriously started panicking and thought that I missed the math midterm. But it turns out they were just all driving back from Spanish really stupidly because they had the math midterm in like
Oh.
half an hour.
yeah. That's fine.
So I got really scared for no reason.
Yeah, I just don't care enough. I don't think I would panic. I think I would just be
I
like, okay,
get
less time to take the test.
less time, like no time to take the test. I don't want to take it on Monday.
JT.
Yeah.
Do you have Kagan?
No, I have Karamanica with Emma.
Dope.
So such a chill class.
It's amazing.
I want to see who's in here.
I didn't turn in that like
Like
that assignment.
Yeah, it's just you guys right now. I'm actually surprised. You know, like when I for like random tests, like we'll have a random quiz and there's some topic that no one paid attention to. Then when I host one of these like at 7, 8 p.m. and there's like 5 or 6 people in here. So it's like odd that no one else joined. Oh boy. I didn't even know you could turn your camera on. I
Oh,
don't
we
have
have a camera on?
Yeah.
Yes.
Oh, wow.
Wait,
How can I see it? This is my house.
Fortunately, I'm not live streaming to YouTube the cameras, so
Are we real bad?
man.
Darn.
I can
My name is
I can
John.
move it into the other tab so everyone can see.
No, it's okay. It's okay.
You know what's so funny? On one of these live streams, Isaac Huang kept saying the hard R. So there's like a video on my YouTube account somewhere, and Mr. Huang's like, I should watch one of your live streams, and I'm like, I don't know.
Did he turn that one on?
Well, I don't think Mr. Huang watched any of them, fortunately. But Isaac kept saying it, and I was like, I can't be bothered to edit this out because it's gonna take too long. I just like post the raw thing. So
My leg is asleep. Oh.
Yeah.
why are you guys at the same house? What's the reason for that? To study?
Because I was studying alone and I got sad. So I said, let's do a study group at my house.
Oh, fair enough. Last year for the physics 1 and 2 midterm, I biked there, but I was like a bunch of my classmates. I was jumping off the sidewalk because my bike was on the sidewalk, and they put a lot of salt on the ground. I didn't realize, so that lowers the coefficient of static friction, and it caused me to slide out. And then I was like bleeding, and then I just walked into the midterm bleeding, and I was like, when you get the chance, can have a band-aid. It's pretty funny.
That's so crazy, man.
I hate physics. Is it too late to drop out?
Yeah.
Is it too late?
Technically,
Well, I
can
think
legally drop
honestly, I have to say like physics 1 and
Which
2 is hard. Physics 1 is hard, but physics 2 is something else because it's just random stuff. But like the benefit is if you take 1 and 2, you get a better teacher.
Yeah.
Yeah.
Physics 1 and 2 you're gonna have a better grade for because you actually know what you're gonna do.
And you have Marv.
Yeah. No, you guys, Delaney or Marvin, it's kind of a lost cause.
Evil.
Eric texts me, I'm gonna go to practice. I date these live streams for my studying help, Loki.
Eric. You're carrying the entire grade.
Yeah, but no one sends me questions. Like I did one yesterday or like 2 but usually I think Mr. Huang's doing a brief study session at 7 p.m. But I know he's not gonna get anything done.
Mr. Huang?
Yeah, our teacher.
Is he doing a live stream?
I wish Marv did
Yeah,
that.
he's doing a Google Meet, but I think it's only gonna be for like 30 minutes. I don't think he'll answer more than one question in that time.
Why do I have Marv? Guys, I actually started out with Delaney and they have 70-point curves.
It's crazy.
Oh yeah, you guys get we have the square root curve, but don't you guys get like a +20 or something?
We don't because we
Plus
have
20
Marvin.
max. We have plus 10 usually, plus 5 to plus
Oh.
10.
Because
So-
we have Marvin, so it like he does it in our class average, but Delaney has like 6 classes and they're all idiots in every single one of their classes.
Yeah, we have Antonia in our class.
And like
We have the Emily and Sarah sisters, and they're
we
so
have like
smart.
all the smart kids and all the kids with tutors.
Hey,
Yeah.
You know what was so
Like,
funny?
Michael isn't helping.
Michael's kind of a he helps, but like he's kind of a ditz, bro. Like sometimes he's like, I'll have to get back to you on this one. Like, okay, bro, just leave
the
it
question
alone.
I gave you with the pulley, Michael spent at least 15 minutes on.
I don't even know who Michael is. Oh. No, I muted the live stream so they can't hear you guys talking because I realized that could go wrong. Just for now. Oh no, I'm not worried about you guys saying bad things. It's more about people hearing things. I don't know. I don't know. I don't even know what I was saying. I don't have a camera plugged in right now. Thank you. Thank you. I should be an actor. I could play like a troll or like a little midget. Thank you. I could play young Sheldon. Do we have... Is there anything else you guys want to review?
How is JT gonna have cookies?
JT, how are you gonna have cookies?
I ate, frankly, I ate like 10 Butterfingers when I came home, so it's best that I don't.
You didn't have these.
You don't have these
I'm
on.
embarrassed to tell
That's
them what
fair.
they were. What are they? Treasure balls.
Treasure balls?
Treasure
Your
ball.
mother loves them. It was your grandmother's cousin's recipe.
Oh.
Treasure balls. I like that.
I don't have any specific questions. It's just like my issue is I understand the basic concepts because in the slideshows it's such easy questions, and then on test, even the AP classroom questions I'd say
Oh,
are
I
easier than
agree.
history.
That's always
And
how
then the
it
tests
is.
are impossible. And then literally, we had a question where he had to chat GPT the answer because he couldn't figure it out himself.
Oh yeah, he wouldn't give us back the.
Mr.
yeah,
Huang
he
did
told me-
that one time, but I think he was just too lazy to do it.
It was an easy question too.
No,
and we
like,
all got the same answer.
He tried it.
He tried it for like 15 minutes.
Oh, sometimes I see Mr. Huang teaching Mr. Marvin physics before our period.
Yeah.
So
Of course he is.
Dude, he's like swearing random stuff, and he's like, I think that's how we do.
And we called him out, and he was like, "We're learning together, guys."
is he a
was
physics
like,
teacher?
"Yeah, I'm figuring it out with you guys," and he gets it wrong, and he spends like 15 minutes doing it. And it was like
Why is
one
he
of the
qualified
40
to teach
questions.
it?
of the test. He's not.
Nepotism.
You know, we should get like questions about his life, like how he met his wife. I would pass
About his paddleboarding shop.
His chiropractor appointments every
Every
Friday.
and his coke and his rum and coke also after.
Oh, yeah. After a long day of school.
You
He's like a
guys are
Jack
very
and Coke
like
fan.
experts on his life.
Yes.
And there's the beach house that his wife lives in. He
Oh,
lives
yeah.
in the coastal
No,
house. the
yeah,
coastal house.
no. He lives in the coast house. His wife lives in the country house.
Country house, okay.
Yeah,
Yeah.
and hands out change
Karen.
for Halloween.
Karen.
Yeah.
Yeah.
He has great customer service at the Southwood House.
You stalked her.
Yeah.
He has great reviews on Yelp.
And their marriage got better after they started living in separate houses.
It sounds like you guys pay a lot of attention in class, but
We do.
We want to learn physics. We don't know anything.
imagine if I feel like you guys might have been better off in 1 and 2, even though 2 is so much harder. But like,
Honestly,
You want to see Minnie? That's
Who's-
Minnie.
It's her
oh,
dog.
She bit me a couple months ago.
Oh, month. It was
a year ago.
years.
It was 1 year ago.
Years.
1 year ago. Almost exactly 1 year ago.
Oh yeah, because there's
It
the
was
satire.
Yeah.
The satire project?
The Satire Project.
I still have it.
Oh my god. She is like pretty princess. She had little bows in her hair, but they fell out.
A tiny little scar. It's like kind of gone. You probably can't even.
Minnie
No,
is a
I
perfect
can't.
friend.
The quality's not good enough.
Yeah, my quality's not good.
I don't even know what to review because I don't know. People sometimes send me good questions but like no one sent anything. Like you guys sent a few, but
Like,
I just like, is she okay?
what?
Jump. That was her
That
jump.
was all her. That's all
no, I don't care. She just fell straight.
Yeah, that was all her.
Okay.
Let me think.
Have you guys done a parent weight?
What?
No,
do you know what a
asked us
parent-
Oh, parent.
So it's like let me give you an
space.
example. A person's in an elevator, right?
We
Let's
did
Oh
do a
yeah, when the
parent
elevator
weight.
goes up and like the weight is different.
do you know how to
elevator
do
goes
it though?
No.
So let's say I said,
He
right,
2 seconds on the slide and then started talking about his life.
Yeah.
a person's in an elevator, okay? Let's say the elevator's going upwards at an acceleration of we're gonna say 2g, all right?
Wait, did you unmute the live stream? Remember to do that?
Yeah, I did. So now if you say curse words, it will be public.
Oh no.
Oh, fudge nuggets.
Now you can say the hard R. It won't be as bad as the things that have been said on here. All right. So this is what we have. So we're gonna pretend the person's a dot. So like they're a dot. There's 2 forces acting on them. Force of gravity downwards, and obviously they're accelerating upwards because the elevator's moving up at 2. So that means the force of normal Fn is going to be bigger than Fg because they're going upwards. That's the free body diagram of the person. Okay. So since we're given that everything including the elevator is accelerating at 2g, we're going to use Newton's second law, which says mass times acceleration equals F net, which here we said it's equals Fn minus Fg. All right.
Oh, I have another question.
Yeah.
Sorry, Brandon. No, it's done. Sorry. My question is, I saw a thing about Newton triples or something. Newton lost triples.
Newton's third law.
No, something triples.
What the heck?
I
I'm
don't have
Googling
a
it.
clue what I've never heard of anything triples in physics. Wait, let's see. Oh, that just the Newton law triples just means his first, second, and third law. Just means
Oh, because he never explained that, and then they were asking me about the Newton's triples. I was like, what is that?
I've never heard it referred to as that, but I googled it. That just means it just means the first 3 laws. That's all it means. All right, so we have ma equals F net. Let's say the person is let's say this person's Emma. So this person's gonna be 90 kgs.
Oh my
Okay.
gosh.
Because Emma probably weighs
Look at
90
Mr.
kg.
Market's weight.
Nah, he's not. He doesn't weigh that much, surely. So we're gonna find how much it feels like they weigh, and we're gonna assume gravity is. We're gonna assume it's 10.
And I actively browse at KK.
All right. So let's do this. So the elevator is accelerating upwards at 2g. All right, and we have Fn minus Fg.
Sorry.
Hmm?
No, also feel locked in. They're like,
Yeah, I was
You said
tuning you guys
90
out.
kg, and it reminded
used
me
to
of the
this.
time that my friend who uses kg said his weight, and I asked if it was pounds in kg.
Oh. Okay.
And it was
So we have he's accelerating upwards at 2
Yeah.
g's, and we have the F net is equal to this, which is Fn minus Fg, and Fg is mass times gravity, which is just m times g. All right. So apparent weight is actually the normal force. It's how much it feels like you're pressing down. When you're standing stationary on the ground, your force of normal and force of gravity cancel each other out, so they're equal, because when you're standing on the ground, you're at a constant velocity, right? You're not going up or down.
This is saying that the normal force is 2 times the gravity, right? So the normal
Oh,
force
well,
is
this is
20?
going to become 3 times. Look.
What?
So I'll show you. So the elevator is accelerating upwards at 2g, right?
Okay, yeah.
So Newton's third law is F equals ma. So our F net is Fn minus Fg, because Fn's bigger than Fg, right? Because he's going upwards, and Fn's the upwards force.
Yeah.
So Fn's bigger than Fg. So ma here, for a, we plug in 2g, because that's the acceleration of the elevator and the person.
Acceleration and person. Okay, yeah.
So now when we solve this equation for Fn, we get 3 mg equals Fn.
Oh, because you add another mg.
And apparent weight, if you think about it this way, when you're sitting on a chair right now, the force of gravity is acting downwards on you, but normal force is acting upwards, and they're equal magnitudes, so they cancel each other out because you're at a constant speed of 0 meters per second right now, right?
You're not accelerating up and down.
Because your Fn is equal to Fg. So what you feel like you weigh, well, we said you weigh 90 kgs, let's say. So that means you feel like 900 newtons because you're feeling your normal force. That's what you feel. You don't feel Fg, you feel Fn. You feel the floor pushing against you.
So much force.
Yeah. So you
much
feel
power
like when you're sitting down,
work.
Emma, since she's 90 kgs, she feels like 900 newtons.
Wait, I'm not on a diet though. I'm like 100 kg at least.
It's alright. Good enough. So, but now we found the normal force when the elevator is accelerating upwards at 2 g's. You found that the normal force is 3 mg's. So 3 times mg was 900, right? So that's 2700 newtons. So we found that you feel 3 times your weight because your weight is mg. That's weight. So
That's not
normal.
bad.
Does it make sense?
Yeah, the question isn't bad. That's not a bad question.
Oh yeah.
What was the question? The
No,
question
I was
is,
saying that the question that you're doing isn't that hard.
yeah, no. It's just saying
Well,
how
it's
much
more
does it
than-
feel like you weigh? So how much you feel like you weigh is not Fg, it's Fn, because it's how much the floor pushes against you. So you get your 3 times your weight. So Emma feels like she weighs, what is that, 270 kgs when the elevator is going upwards at 2 g's.
I'm feeling a lot of force.
And you
That's
could
not bad.
you could
Lot
think
of
of it the opposite way. Let's say we said the elevator is going downwards at what is that, negative g, right? Let's say we said the elevator is now dropping at the acceleration of gravity, meaning the elevator is in free fall. Okay, so g. So that means if we solve this now, what do we get? 0 equals Fn. So that means the person's also going to be in free fall. So the floor is not going to be pushing against you. It feels like you weigh nothing. You're just going to be floating. And Fn can't be negative because the definition of Fn is just how much the floor is pushing against you. It's a contact force.
Wait, when does Fn equal 0?
When the elevator is dropping at g meters per second squared. Yeah. So that means the elevator's in free fall, but so will the person be. So like you can kind of float around inside of it. You'll feel like your stomach's dropping. But if the elevator accelerates any faster than that, what's going to end up happening is you'll end up hitting the ceiling of the elevator. But let's say the elevator was going at negative 2g. At the start of the situation, you would get your answer to be negative mg. But normal force, like I said, can never be negative because normal force is how much it's pushing against you. So it can't pull against you. That makes no sense. So that if it's negative, that's the same as it not pushing against you. So like if you got a negative Fn, that means it's not pushing against you. That's all there really is with the parent weight. Not much more to it than that.
Makes sense.
Yeah. I am actually surprised no one's come with questions. It's very weird.
I have another question.
Yeah.
It's kind of like a stupid question, Nana.
There are no stupid questions.
I'm waiting to hear this one. So this is like a basic concept that I just never understood. There will be times where it's like Fg minus Fn equals blah blah blah, and then there are other, or like it would be, I wrote it down.
Around the loop.
T equals Fg plus Fn.
Tension equals Fg plus Fn.
There aren't there times where it's like,
yeah. You want to know why that would happen? Sure.
Yeah.
So let's say we have an object. You're spinning something on a string, right? Okay, it's on a string. Let's say this is the center. You're spinning. I'll draw it like this. We have some sort of ball, and it's on a string, and it's being spun around. This is the axis it's rotating around. It's rotating around this way. Okay, so you kind of have to imagine that's vertical. So like that ball's above the point it's rotating about. So right now, if we draw the forces acting on it, Ft is this way. Actually, well, it might be the other. I don't actually. Why would you have tension and normal force at the same time? That would be like that would be
that
very.
was AP class. No, that was me. No, it was me messing it up.
Yeah, I figured that's the combination was weird. Sorry.
But aren't there times where it's
You
like
could have, you know what you could have?
minus
You could
Fn
have Fg equals T plus force of normal. So that could be like, let's say you're pulling a block and the block is
Yeah.
on the ground, and then you're pulling it upwards with a string. You could have that. If you split it into the vertical components and the horizontal, you would have
We have problems like that a lot.
you do? Yeah.
Mm.
If there's no friction here, let's say, so this is FT, right? FT. We could say that's 100 newtons, okay? And then this block is going to be 10 kgs, all right? It could ask us something like, what's the normal force on the ground, right? So how would we set this up? We would break the 100 newtons into components. We have the vertical and the horizontal. That's FT. That's tension. We would have to know the angle it's pulling up at. So let's say, for our purposes, this is 45 degrees. That means since sine of 45 degrees is equal to opposite over hypotenuse, if we multiply the sine by the hypotenuse is 100 newtons. So it's 100 newtons sine. That'll give us the opposite, which this side's the opposite here. So we want to find that. That's the vertical. So that's going to be Ft vertical, okay? Equals Fty, force of tension in the y direction. Now, if we set up the free body diagram for this block, we have 3 forces acting on it. We have gravity going downwards, Fg, right? We have the tension of the string is going upwards, Ft. But one other thing to note is that the ground is pushing up on the block, so we also have normal force going upwards. I just drew the arrows offset, just so I have space. So we have 3 forces acting on it in the vertical direction. And we found Fty. We can also easily find Fg. Fg is mass times gravity, which is 10 kgs times 10 meters per second squared. So now if we want to find normal force, we have this setup. We have Fg, since in the y direction, let's say we were told that the block is not lifting off the ground. That means that it's at vertical stable equilibrium because its vertical velocity is 0 and constant. It's not going up, it's not going downwards, it's staying there. So the forces cancel out in the vertical direction. So we have Fg is equal to Fty plus Fn. Let me make a correction. This is Ft's not in that direction. Ft. Okay. It's plus Fn. So we have, this is 100 newtons was gravity we found, equals Fty was 100 newtons times sine of 45. So that's 50 rad 2 newtons equals Fn. That's sine of 45 is rad 2 over 2 times 150 rad 2. Okay, so if we just subtract those two, I'm not doing that, but this is about like 1.4 times, this is about 30 newtons, I believe. So, yeah.
It's actually 29.28. Thank you very much.
Give me a break, bro.
How did you know that?
It's actually so cool.
I approximate. I know that rad 2 is between rad 4 and rad 1. Rad 4 is 2, so it's between 1 and 2.
Oh, so you guesstimated like about a little less than 1.5.
I guess it's 1.4. Yeah.
1.4. Yeah. Okay. Makes sense.
These chairs. It's these chairs.
Use your calculator. Don't guesstimate. Yeah. Guesstimating's bad.
Yeah.
Okay. Well.
But
Wait, can you pretend to be me and take the test?
Can I pretend? Do I look like you?
Yes.
Yes.
We both have asthma. I can just be like, I can't breathe.
I say that as I wheeze laugh.
I know.
We'll just wear a brown wig.
I'll just wear the
Maybe
inhaler in my
here.
mouth. I'm Emily.
Wow, we're the same height. It works.
I think you're taller than me.
No, I think we're the same height. I'm
Maybe.
5'8", and you're like
Yeah, I'm not
5'8".
5'8".
You can wear heels. It's okay.
I'm gonna wear
5'9".
heels.
JT is 6'7".
I don't think you found that very funny.
And the fact that you can't see his face is just silent.
I know. I'm sorry. I don't have a camera in my room right now. But then you would just see me laughing at your question.
I needed to say that.
What happened?
Nothing.
What I said?
No.
What did you say?
No, wait. Not a good.
Yo, muting is crazy. I'm gonna start lip reading. Okay. Do I want? I don't want to know.
No, it's all nice things.
Yeah, it's really
You're
nice.
like very nice.
Yeah, very nice person.
I was trying to lip read. I can't lip read.
We're being nice.
Yeah.
Is grandma gonna snitch on you? I'm team grandma.
I don't think like
You don't even know her name.
What?
What's her name? What do I call her?
I already forgot.
Yeah.
Nana. My bad.
wow.
You know,
I'm team Nana now.
the dog in Peter Pan.
Oh, yeah. It's so funny.
Sorry, I had to like, get
Because
that off
wait,
the chest.
pause it for a second.
Yeah.
What? This is not
Oh my goodness.
It's the only thing to keep you off of black pill TikTok and
The maximum. Wait, what's it
the
called?
clavicular guy.
Yeah, the curricular.
Isn't he like a Nazi or something?
What? Probably. He
Wait, no,
injects
he's
himself.
isn't he
He
friends with Nick
snorts crystal
Fuentes?
meth. He fully admits to snorting crystal meth.
Oh, good. Trash can. Even though we're flowing, I fixed it. The dad's not home. He's MIA.
But he doesn't do garbage anymore.
He does garbage like once a week.
Yeah.
Sometimes.
He occasionally does it.
No, like a lot of my friends are like super into BP. It's like kind of like
I don't even know what that is.
Ooh.
scary. Like Chris. Like I don't think you know these people.
Chris is the blonde one.
Yeah, that one, and also like Chris Kim. and, like-
Bro, Chris Wong is your friend.
I know you guys don't like each other.
Bro, that is. I mean,
But
Understatement.
JT is friends with interesting people.
well, first
you,
of all,
Jake.
I'm not
Like
friends
that.
with people who post themselves like shirtless like
They're
10 days a
friends.
week.
A week after we broke up, they were posting together.
It's are you friends
I'm
with
talking
Andrew?
about with who?
Andrew.
We're not like close like that. Like we talk occasionally. We're not like close friends, you know.
Ew.
I'm friendly with
Yeah,
him,
stinky,
but I
stinky.
wasn't referring to him. I was talking about Mr. Chris Wong who posts himself
Yeah.
flexing his
Oh
ab
yeah,
muscles.
I know you don't like him.
Uh,
It-
so you're saying you enjoy seeing that on your feed?
No.
Exactly.
Like I understand why he's like on live. Wait, is this on live stream?
Wait. Let me low key. Let me mute everything. I can mute. Nah, I ate too many sweets today. I don't really need to cut, frankly. That would not be healthy. You're a little bit off. I'm a little more than 32. Multiply by like 2.2. That doesn't mean anything. Bro. Wait. Someone asked me for help with that lab and they miscalculated. They had like a lot of power and I'm like, it says you weigh 90 kgs, like legitimately. And I was like, if this is, and I was like, there's no way at your height and like stature that you weigh 90 kgs. I was like, you gotta be 60 at the most. And they were like weighing 90 kgs on their paper. Something like that. Not 90 pounds, I don't know. I think they just messed up, like their measurements were inaccurate. Oh, Lee Howe had really high power last year. I don't even remember. Yeah. Did you have sneakers? Lee Howe was sprinting when I did it with him. Yeah. Oh, he had a lot, but that's like because of mass partially. But he went really fast. He was like took it really seriously. Like he was like, Miss Donahue. I just randomly, yeah, no one joined. What? What? Priorities, right? I'm so old. I'm almost 18. Oh, when's Chase's birthday? Wait, so together you guys are 16 and 17 and 6, 7. Oh my god. It's legal. No, it's illegal to smash. It's legal to date.
G-I-A-N. The J in Italian is John, not Jean. So I was like, no, it's John Coley. And he was like, you're dating a guy who lives in Italy. I'm not dating a guy who lives in Italy.
I see.
It's really weird.
It looks like E. coli.
Stop.
His name has never been revealed.
Stay under there.
Shut the frick up, dude.
Who is that? I can't see the name.
Oh, there's thousands of that way.
Who is
That's
that?
That's my close friend story.
Oh. Wait, who is that?
A kid from like a camp that I went to.
Why are you
The
posting
concentration
autistic
camp.
kids?
Wait, why is shit was actually?
Let me go post Emily on my close friend story.
I'm on your close friend story.
There's
Yeah,
70
I'm on your
people
close
on mine.
story.
What?
Exposing yourself.
Exposing yourself.
Oh no, there's 71 on it.
There's 71 people on your close friends story?
Yeah, I don't really like. It's just like, who is least likely to report me? You know, that's.
I don't care enough to report.
Yeah,
I'll
exactly.
report you.
That's why you're probably on it.
Wait, guys, Ishan knows Joey.
Who? Okay.
Who? Who's that?
Wait, yeah, on his story. I screenshotted it because I knew it'd go. This is what he posted on his story. Where is it?
Ishan Goat knows Joey.
Ishan Goat. This is what he posted on his story, right? Who's that?
Oh my god! How'd you even zoom in that?
No, because I like what?
Emma's such a stalker.
No, I wasn't. This is his story, and I know
Emma
that
is
guy.
such a
I was
stalker.
like, he looks so.
It's Emma such a stalker.
I know.
Yes,
No, but I
she
was like,
is.
he looks so familiar. So I slid up on his story, and I was like, whoa, is that Joey? And he's like, what? How do you know Joey? How are you two connected? What the hell?